In mathematics, if you want to prove something, two things are important for us. One of them is what we know. The second one is what we need to prove. So to be clear that we should write them at first. We know that our sequence is convergent. So we need to assume that a convergent sequence. Let's say that our sequence is an. So if it is convergence, it converts one real number. Let's say that our sequence an converts to a. So in here we need to prove that the sequence an is bounded, right? So we need to show that the sequence an is bounded. And also the definition of boundedness says that we need to find m, there exists m, such that for all n, absolute value of an must be less than m. So for all terms of the sequence an must be less than one real number m. If we can find m value that satisfies this inequality, we prove that the sequence an is bounded. But how can we do that? We only know that the sequence an converts a, right? So let's remember the definition of the convergence. For all epsilon which is greater than 0, there exists n, right? It starts from like this. For all epsilon, we have n, and absolute value of an minus a will be less than epsilon. Again, for all epsilon. So we have this definition for all epsilon values. So we can pick one epsilon. I choose 1 for mathematical beauty. You can pick epsilon is 1 over 2, 1 over 4, or 2, 5, 10. You can pick any epsilon because you have this definition. Then you always have big N such that for all n they are greater than big N, we have what? Absolute value of an minus a is less than epsilon. But we said that epsilon is 1. So we have absolute value of an minus a is less than 1. So why it is so important? Because this implies that, do not forget what we are trying to prove, that for all n values we need to prove that absolute value of an must be less than m. By using this definition, we know that for all n which is greater than n, for all n which is greater than n, we have this inequality, right? Consider absolute value of an. I can write here absolute value of an and minus a plus a, right? Because here is 0, this is actually absolute value of an. Why I am doing this? Because I want to use triangular inequality. In here, consider this term and this term. If you apply triangular inequality, we have that absolute value, this is less than absolute value of an minus a plus absolute value of a, right? I applied triangular inequality. Why I am doing this? Because from this definition, when n is greater than big N, absolute value of an minus a is less than 1. So here is less than 1. So I can write here is 1 plus absolute value of a. So we prove that absolute value of an is less than 1 plus absolute value of a, where when n are greater than big N, right? But in this definition says that you need to prove that absolute value of an must be less than something for all n values. But we prove that only for when n are greater than n, big N. But consider the sequence. Our sequence has the first term. So what about the absolute value of our first term? What about the absolute value of our second term? What about the absolute value of our nth term? We only prove that absolute value of n plus 1, absolute value of n plus 2, and it goes to infinity. We only prove that this term, and all these terms after this n are less than 1 plus absolute value of a. We can call that this is m. So all terms are less than m. But what about these terms? We don't know what are they. So how can we decide that this one, a1, absolute value of a2, and absolute value of a big N, and the rest is always less than 1 plus absolute value of a? But how can we decide that these terms are less than one number, one real number m? Maybe a2 is the highest value on these n plus 1 terms. Do not forget that we have 1, 2, n plus 1 terms in here, right? We don't know which one is the maximum. Think about that. If your sequence is decreasing, maximum term is a1. If your sequence is increasing, maximum term is 1 plus absolute value of a. If your sequence is not increasing or decreasing, maybe your maximum term is a5. You don't know what is it, but you can denote that. Actually, it's not important which one is the maximum one. You can denote that m is the maximum of this set. This set has capital N plus 1 terms, right? We have n terms in here and also plus 1. So let's say that m is the maximum of these values. That means for all n, we have what? Absolute value of an is less than m. Because if it is a1, a1 is less than maximum or equal than m, right? Well, let's say that for be sure, less or equal than this m. So if a5 is the maximum in here, so all terms are less than a5 because a5 is the maximum. Or think about that, if an, a big N, is the maximum value in here, so all terms are less than big N because an becomes the maximum value. So you can easily say that for all n, the absolute value of your terms are less than m. So we can say that our sequence is bounded because we prove that for all n values, they are all less than m. We found our m in here. And vice versa. What if your sequence is bounded? Is it convergent? Think about the converse. If your sequence is bounded, is it convergent sequence? The answer is not. Because let's define our sequence an is minus 1 to the power n. So your first term is minus 1, your second term is 1, your third term is minus 1, and it goes like this. So you can say that absolute value of an, it is already less than 2, right? Or you can easily say that it is less than 3, it is less than 4. Actually, you can say that absolute value of an less or equal than 1. But this is bounded, but it is not convergent, right? Because limit an do not exist. It is not 1, it is not minus 1. The limit is not exist. So boundedness do not satisfy the convergence. The vice versa is not correct. So that's it. For more real analysis videos, you can subscribe my channel. Thank you.